Assalamualaikum. Hi guys. In this video, I'm going to explain a bit about Rydberg equation. We are going to use Rydberg equation when we want to determine the value for wavelength emitted by the transition of electron between two energy levels. In this case, you have another one new formula to calculate the wavelength. This is the lambda, the wavelength that you are looking for, and you got 1 over lambda equals to Rydberg constant times with values between two different energy levels. Based on this formula, you have lambda, your wavelength, the unit is meter, and the next one you have Rydberg constant, which will be the new value here, 1.097 exponent 7 per meter. If you realize here, the value for this Rydberg constant is quite different from you've learned so far. So please remember, you got two different values for Rydberg equation. When the formula 1 over lambda is being used, you have to use this value for your Rydberg constant. By using this formula, you have to take note that your lambda should be positive value. That's why N1 must be less than N2. So let's try one example together to calculate the wavelength of fourth line in Balmer series of hydrogen. So for this case, I know that Balmer series, the ground state or the lower energy level will always be N equals to 2. So this is going to be my N final. Now I'm going to determine the fourth line. So for the fourth line, we are going to use the next four number after 2. It's going to be N equals to 6. 6 is going to be my initial because it's for 6 energy level. Now I have this formula where I'm going to make sure the value for N1 must be less than N2. So between 2 and 6, which one is going to be N1 in this formula? It must be 2 because 2 is less than 6. So I put the value into the formula, rearrange the values. You will have the answer for 1 over lambda is this one. But what I'm looking for is the wavelength. You will have 4.10 exponent negative 7 meter. This is where you have 1 divided by 2.48 exponent 6 per meter to get this wavelength. It is advisable for you to write the wavelength in unit nanometer, whether the question asks you or not. But if the question asks you specifically in nanometer, you have to put in this unit. So depends on the question given. Now let's try one more example by using this new formula for Rydberg equation. I have example 16. I want you to determine the wavelength in nanometer. This is very specific unit, the frequency and energy that associated with the second line in Fun series. So first thing first, take out the information where you have Fun series, the ground state will always be N equals to 5. Next, you are needed to determine the N initial for the second line. So the next two number after 5 will be 7. So this is N initial. You got the formula? N1 must be less than N2. So between 5 and 7, you got 5 is much more smaller than 7. So N1 will be 5. Put the value together, you will have the wavelength 4653 nanometer because the question asks you specifically the wavelength in nanometer. Next, I'm going to use this information for the value of wavelength to calculate the frequency. So I got this formula. Put the value for speed of light, you will have the frequency is 6.447 exponent 13 per second. Please remember you have to put the units for the value that you are looking for. Next, we are going to continue with calculating the energy. So for the energy, we have the information given. Now I got my formula for the energy difference equals to HV. This is where I'm going to use my frequency value that I got from the previous slide, put into this formula, and the final one, I will have the energy difference is 4.274 exponent negative 20 joule. Let's try one more example. I want you to determine the transition that produce a green line with wavelength is 486.3 nanometer. What you have here is green line. So how you want to know which series it is referring to? I've taught you before, for the series that is visible with a specific color, it is only referring to the Balmer series. So in this case, you know that the value for the ground state of Balmer series will be always equals to 2. So this is NF, your N final. Now I'm going to determine what is the N initial for this green line with its wavelength. So use this formula to get the value for Ni. But right now you have to take a look carefully. In this case, we can know that Ni is referring to N2 because we want to find out the value for the transition of higher energy level. So I'm going to put NF is N1. So you got here 2 square for N1. Rearrange the value for your calculation. Press the calculator correctly. You will have N2 equals to 3.998. You can round off to get 4. So the final conclusion, it asks you to determine the transition that produced this green line. So you have to describe in one statement. The transition that produced the green line is from N equals to 4, this is higher energy level, to N equals to 2, this is lower energy level. Specifically for this question is Balmer series. So from this video so far, you've learned there are 2 different Rydberg equations that you can use based on its different values. So now we are going to determine its usage. The first one, you have RH equals to 1.097 exponent 7 per meter. This is where you have this exponent value, where this value should be used in this formula, 1 over lambda. In this case, please make sure your N1 must be less than N2. Next, I have another value for Rydberg constant is 2.18 exponent negative 18 joule. So the unit is different right now compared to the previous one. This is per meter, this is joule. I'm going to use this Rydberg constant only to calculate the value for energy difference here, delta E. So please make sure when you get the question, you need to know which one you should use. If the question asks you about wavelength, you can straightaway use the first one, the formula for 1 over lambda. But if the question asks you to calculate the energy difference, you can use the formula to calculate based on this one. Let's try one more last example in order for you to understand which Rydberg constant that you have to use for this question. First thing first, I want you to calculate the wave number and the energy liberated when an electron from 5th energy level falls to the 2nd energy level in hydrogen atom. This is a new term for you, wave number. The symbol will be 1 over lambda. Now, we are going to take out a bit more information here. You got 5th energy level and 2nd energy level. So I'm going to label this one as N2, this one as N1. This is because you have to make sure the N1 should be less than N2. So 2 is much more smaller than 5. Now, it asks you to calculate the wave number, 1 over lambda. Automatically, I will use this formula. and put this value for Rydberg constant. Next, insert all those value where you got N1 is 2, N2 is 5. Press the calculator correctly, you will have this value for your 1 over lambda. This is for the wave number. So the unit for the wave number is per meter. And now we are going to continue how to calculate the energy liberated when this electron fall from the 5th energy level to 2nd energy level. So I'm going to use this formula. The value for Rydberg constant right now is 2.18 exponent negative 18 joule. So now, if you take a look here, I already labeled the value for N2 is equals to 5 and N1 equals to 2. But in this formula, I need to use based on initial and final. So, I can also write it down. My N initial is equals to 5 because the word from, and then to the 2nd energy level. So, NF is 2. Now, we are going to insert all those values. Delta E equals to 2.18 exponent negative 18 joule for the Rydberg constant, and then times with 1 over 5 square minus 1 over 2 square, because in this case I need to base on N initial and N final. In the previous formula, I used N2 and N1 because we used the formula 1 over lambda. Now, continuing from this part, I have the value for my energy is negative 4.578 exponent negative 19, and the unit should be joule. So this is the value for the energy liberated, and the sign should be negative as you see from here. So I hope you can understand right now the difference between two Rydberg equations and when you should use them. That's all for this video. Thanks for watching. Bye.